really, in some sense, the key organizing factor. Because the biggest uncertainty in going to the moon and Mars is not the rockets. It's not the guidance. It's really the performance of the humans in the system. So this is just a graphic of the options in the flexible path. That you go to lunar orbit, then to these ligation points, and then to the asteroids, and then you get to make decisions. Whether you go next to the surface, or you go next to a Mars flyby, or you go to some of these and then the lunar surface. It gives us options for how to deploy these resources in the future. So this was the program for human exploration that was existing when we started. That we go to the International Space Station, we end the shuttle, go to the International Space Station on Russian rockets, and then go to flights, again near Earth, and then have a lunar landing around 2030. So this actually didn't allow us to do much other than go to the International Space Station for almost 2 decades. So our proposed plan was actually to continue the International Space Station, but then start going on these trips earlier, and then eventually get to a lunar landing. And one of the important features here is that we were able to identify a means to, we think, save a significant amount of money, which we call the commercial crew capability. But before I get to that, let me explain the question of order or sequence. So everybody says we should go to the moon first, until they calculate the budget. Because to go to the moon, you have to build a capsule which is capable of going to the moon and bringing the cosmonauts back. We estimate that this is an effort of 15 to 20 billion US. So that's $1 billion. And you have to build a big booster, like NAD, Saturn V, but even bigger than NAD and Saturn V. This is 15 or 20 billion US. Then you have to build a lander to go from the surface, from lunar orbit down to the surface and back up. This is at least 20 billion US. And then you need to provide the capability for the humans to work on the surface and move around and explore. And that's another 15 or 20 billion US. So if your first objective is to go to the surface of the moon, you have to do in parallel all 4 of these development programs for a total cost of about $60 billion. And actually, if you go and look at the amount of money that was spent by NASA from 1960 to 1972, and you convert it to current expenses, current dollars, this is just about the amount of money NASA spent. So what's the alternative? The alternative is what we call the flexible path first. So now you can build the capsule and the booster and some small in-space elements and start exploring space first with those for some number of years while you build the capability to have a lander and the surface systems. So this is really just a very pragmatic argument that you have 2 options, and one requires a very high capital expenditure first, and one requires a more distributed capital expenditure. And in this case, it's always better to do the distributed expenditure. So what are the benefits of the flexible path? We would be able to start away from the Earth faster. We'd be able to go to destinations that humans had never visited. We would go to new places each year on the flights and develop the capability to work away from the Earth in deep space. We would be able to bring together the robotic exploration and the human exploration, do some interesting science, have a good expense profile, and engage international partners. So this is the very important point, that we wrote this policy, or we drafted this report, without any specific recommendation of including international partners. But as a practical matter, this program will not be achievable by the United States government alone. That it is absolutely necessary to have a deep and true partnership of the US, of Russia, of Europe, and other spacefaring nations, including perhaps China, in order to achieve this. That this has to be an international effort of high significance, and not just a Russian program or an American program. One of the interesting things that we found as a way to accelerate the program is this idea, that we actually move the job of lifting the crew to low Earth orbit away from the government and towards commercial entities, towards companies. That we should make going into space now a business. And it's the timing of the discussion today is actually very, very good. Because in the next week, if all goes well, an American company, SpaceX, will launch the first commercially developed rocket with a capsule called Dragon to the International Space Station. And that this capsule has been designed so that it can be converted in a few years to a human carrying capsule. And just a few months later, a second American company, Orbital Sciences Corporation, will also launch a commercially developed rocket towards the International Space Station for the purposes of delivering cargo. So we will see, actually, in the next few months, the beginning of this era of commercial launch into space, commercial peaceful launch into space, for the purposes of carrying first cargo and then crew. So watch in the next few weeks for these developments. And because of the way such developments work and are funded, we think that there'll be, the committee believe very strongly, that there would be a net savings of money in the near term by allowing the commercial suppliers, the commercial companies to do this. So when we finally put these options together, we had what's called a decision tree, an applied decision analysis. And you can see that there's some decision on the budget, which is the first line. The NASA budget, by the way, is higher than it was several years ago. And then there was options about which pathway to take, the flexible pathway to move first, and then various launch vehicles, which I didn't discuss today. So when we were completed, when we took the then existing US space program policy and plotted the value that it would create on this so-called radar plot, which is a way of indicating 12 different metrics for the program. Exploration, technology, the ones I mentioned earlier. Science, human civilization, economic expansion, global partnerships, public engagement, schedule, safety, workforce, sustainability, and life cycle cost. You can see that the then current program is shown in the blue trace. And the program that we recommended is shown in the red trace. So in every dimension, the program that we recommended, including global partnerships, in every dimension, the program we proposed had more value and was more desirable than the then existing program. So let me summarize what's happened in the last 2 years. That this report was published, the White House took it as the basis of their budget 2 years ago and changed or chose some things which were not exactly the primary recommendations of our report. There were other options. And the Congress and the President debated this for about a year. Some would say they're still debating it. And I think it's actually quite remarkable that the current status of the policy is almost exactly what was recommended by this commission. That if you read the report carefully and see what our recommendations were, ending the shuttle, continuing the space station, commercial space launch, going more flexibly forward, developing a heavy booster based on the shuttle technology, you'll actually see that most of the recommendations were approved. So I would conclude with 2 thoughts. The first is, as I said, that I think it's absolutely essential that we think globally about how to do this program. And we bring ourselves into true partnerships that are long-lasting about how to go into space and explore. I think that's a general political conclusion. But I would, especially for the young people in the room, the students, I would say that there's another lesson that I've learned from this committee, this commission, which was something that was taught to me by one of my professors. We were one day at NASA Houston Space Center, and we went into this enormous building. And he showed me this experiment that was going on there. And he said, "Ed, do you recognize this experiment?" I said, "Yeah, I recognize this. There's a very small version of this in your laboratory at MIT. And he said, "Let this be a lesson that you have to be very careful in life about the advice you give to governments, because sometimes they actually listen." So students of MGU, who will be future leaders in Russia, remember that if you give advice to the government, be very careful, because they might actually do what you say. And then you would have this great responsibility for the advice you give. So in this experience, I look back and say, there have been many reports written about space policy in the US, but this was a report which actually had some significant influence on the decisions of the government. And I hope, whether President Obama is re-elected or potential President Romney is elected, that this report and this policy are well-based, well-reasoned, and will survive and be continued throughout the next presidential administrations. So thank you very much for your attention today, and I'm more than willing to answer questions, as the Prorector said, either on space exploration or if there are a few questions on Skolkovo Tech.